Welcome to CS 2001 Digital Systems Design, BTech 3rd semesters, Computer Science and Engineering, NIT Rourkela. Today's topic is number systems. The most common number systems that we have been learning from our childhood is the decimal number system, which has got numbers ranging from 0 to 9. A single digit decimal number system has got 10 different possibilities. A 2-digit decimal number system has got 10 cross 10, that is 100 different possibilities. Similarly, a 3-digit decimal number has got 1000 different possibilities. Every civilization in the world have come up with their own number system, but one commonality among them is this 0 to 9. That is, all of them are based 10. But then the story of computers a little bit different. They do not work on 0 to 9 number system. Rather, they work on binary logic, that is 0 and 1. Our civilizations have come up with this decimal number system, might be for the reason that we humans have 10 fingers. Then is it the same for computers, that computers have only 2 fingers? Jokes apart, computers' basic building blocks are transistors. Transistors work either on state or off state. They have got 2 states. And based on these building blocks, the entire computer system is built. But then, having a binary number system in computer systems is actually a boon. The reason is the underlying circuitry becomes very less complex. In order to make you understand this, let me put something like this. Like, let me have a wall. On one side, you are located. On the other side, it's your friend. And let us have 10 different balls. I'll start with B9, B8, B7, B6, B5, B4, B3, B2, B1, B0. And all these bulbs are connected with wires, 10 wires. Of course, you need one neutral wire. Let us not consider that for the time being. So you want to communicate with your friends in terms of some numbers. Let us say you want to communicate 5. You want to say 5. So you will switch on this particular bulb, staying on this side of the wall, and your friend will see that this 5th bulb has grown, so he will understand that you want to say 5. Similarly, if you want to say 8, you will switch on this 8th bulb, and the remaining bulb would remain at off state. So at any instant of time, any one of these 10 bulbs will be glowing. So the number of different possibilities that you can communicate to your friend is 10. That is one single digit of a decimal number system. Now, the same thing, if we escalate to 2 digits. That is, the number of possibilities are now 100, 0 to 99. So what additional things you need to do? You need to put another set of bulbs, 10 number of bulbs, 10 number of extra bulbs, 10 number of additional wires. So in order to communicate numbers ranging from 0 to 99, you require 20 bulbs, 20 wires. In order to communicate numbers ranging from 0 to 999, you require 30 bulbs and 30 wires, and so forth. But then, in case of binary, the number of possibilities for a single digit are only 2. So it's actually only 2 different possibilities are there. So a binary number system will be having only this part, this much, for 1 digit. For more digits, more number of bulbs are required in a binary number system. But then the question is, how many different possible numbers we can communicate in binary? Let us understand that. So again, in binary, you have 1 bulb, so the number of possibilities are 0, 1. If you have 2 bulbs, it becomes 0, 0, 0, 1, 1, 0, 1, 1. Its decimal equivalents are 0, 1, 2, 3. Similarly, if you have 3 bulbs, 3 binary digits, you have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. That is 0, 1, 2, 3, 4, 5, 6, and 7. So there are 8 different possibilities out there. So like this it goes on increasing. In decimal number system, there is a unit place, there is a tens place, there is a hundred place. So every successive weight is 10 times of the previous weight. In binary number systems, every successive weight is 2 times the previous weight. But then let us come back to this bulb, how the circuitry is less complex in the case of binary. So let me draw a graph. I'll have a x-axis, I'll have y-axis. In x-axis, I will put the number of digits, decimal digits, that is 1, 2, 3, 4, and so forth. Here 1 means 1 decimal digit, that is the different number of possibilities are 10. The number of possibilities you have is 10. Here the number of possibilities are 100. Here the number of possibilities are 1000. And here it is 10,000. So in y-axis, we will figure out how many wires or bulbs we require for a decimal number system and for a binary number system. So let me put in this way. We have, let us talk about decimal first. So we have 10, we have 20, 30, and 40. So in a decimal number system, for 10 different possibilities, we have 10, here we have 20, here we have 30 different bulbs I require, here I require 40 different bulbs. So this is how it is increasing. But the same thing, if I put for binary, if I draw it for, So for 10 different possible combinations in binary, I require 4 different digits. Here I have written from 0 to 7 with 3 digits. One extra digit if I put, it would go up to 15. So 10 is within that. So I require 4 digits. So the first, this 10 possible combinations can be drawn using 4. That's 4. 100. For 100, the number of possibilities are 2 to the power 6 is 64, 2 to the power 7 is 128. So 7 different possibilities are required. 7. For 3, that is 1000 different possible combinations, I require 2 to the power 9 is 512, 2 to the power 10 is 1024, so I require 10 number of words. And similarly, for 10,000 different possible combinations, I require, this is 2 to the power 10, 11, 12, 13 is 8192, 2 to the power 14. I require 14 different possible combinations. Sorry, 14 number of bulbs. So it will increase in this way. That is what the whole point is. The number of wires, the number of, more the number of bulbs, more the number of wires. In fact, you please understand that here we do not have bulbs. In case of computers, we have transistors. So more the number of transistors, more the number of wires, more complex the circuit is. So decimal is much more complex in terms of circuitry than the binary number systems. So that's all for today. So before I conclude the session, let me write something so that there are there are 10 kinds of people in the world, one who can count in binary and others who cannot. So if you do not follow this one, let me put a base 2 here. Thank you everyone.